Welcome to 1.3 Measuring Angles. Let's get started here. We've got an angle is two rays with a common endpoint. You could also say a shared endpoint. And you can name an angle by its vertex. So for instance, if I just draw here, it's an angle. Here's a point right there. I'll just call this point A. We can realize that my picture is supposed to be over here. We can call this angle F. We can do the same thing using a number. So again, I'm just drawing an angle here, and the number, let's say I use the number 1, will go on the inside of the angle. Okay, so there we go, like that, and we'll call this angle 1. And then we can do it with using more letters. Okay, so let's go ahead. We're going to draw a picture, similar kind of picture. I'll make this one a little bit more obtuse, like this. There's an obtuse angle. Remember, obtuse are greater than 90. And I'll go ahead and label this with 3 points. We'll call this X, call this one Y, and that one Z. So what we can do is we can call this angle X, Y, Z. We could also call this angle ZYX. But what I cannot do is call this angle XZY or ZXY. We always have to have the center letter of the name be the vertex. The vertex in this case is 1. So here we have the measure of angle DOG, it's a nice name there, which is going to be 52 degrees. And we can call, so the angle DOG can also be equal to angle O, we could call that. We could also say that this is angle GOD. Okay, so let's talk, we talked about in our last lesson the difference between equals and congruent. So when we're labeling these equals here, we're talking about a measure of. That M, and just to here as well, the lowercase m means the measure of, and then we're typically talking about an angle. So I'll abbreviate that with that symbol for angle. So then we've got angle A is equal to 70 degrees. Now, because this figure is pretty small, I'm going to go ahead and draw a little arrow right there. I'm going to put 70 degrees right in there. And then it says BCA, so C is the vertex, so that's going to put it right there. That says it's also 70 degrees. So then you can say that the measure of angle A is equal to the measure of angle BCA. From over here it says that we've got angle 1 is congruent to angle 2. Now we don't know the measure. It certainly looks like these triangles are congruent to each other or the same, but treat this as a separate problem. What we'll do is we'll label these 1 and 2, and what we can do then is do a couple things. We could say the measure of angle 1 is equal to the measure of angle 2. So these statements, though they're read differently, mean the same thing. We've got angle 1 is congruent to angle 2, so these are the names. The measure would refer to a particular measurement, which we don't know yet. And then what you can also do, so we've got 1 and 2 there, I want you to keep in mind that when we typically talk about congruence, we typically put little arcs on the inside there, just like that. So then maybe I would label with like a little arrow like this, 1, and then this would be 2. There's different possibilities there. So as a result, it's making this triangle an isosceles triangle. Let's practice using a protractor. So I'll come on over here to my tools. So, see where that was placed. Okay, it was up here. So we'll bring this down here. Maybe make this a little bit smaller. When we're measuring an angle, which you've likely done before, but maybe it's been a while, you might kind of forget how to do that. What I want to do is make sure the middle of the protractor is right there on the vertex. And I want to line up this bottom part with one of the lines. So I could do it, I could go this way. Yeah, this is lined up over here, but it's upside down, so I don't really love that. I'm going to put it right side up. Boom, there we go. So you see the 0 degrees is on this one. And you notice that this angle is acute, so that means it's going to be between 0 and 90 degrees. So the question would be, do I look at the 45 here, or do I look at the 135? Well, 135 is bigger than 90. That's obtuse. So I'm going to be using this 45 degree measure. So you see 40 to 50, it's right in the middle. So right here, you can even, I can make it bigger. You can see how it goes through right in between there. Okay, so let's go ahead and right here, I'm going to label this as 45 degrees. I'll come over to this one here, make that a little bit smaller. Line it up. There we go. Maybe move that up just a little bit, get a little bit more accurate. I really want that bottom line to disappear. Okay. So now take a look. This is the 0. I keep moving along this way, and looks to me like it's 104 degrees. So 4, which is obtuse, and you can see it looks like it is obtuse. Okay, so classifying angles, you've heard me mention this already, so let's go ahead and get some definitions in here. So an acute angle is going, and I'm going to use this symbol, this is theta, and that's used for unknown angles. It's a Greek letter in the Greek alphabet, but it's used mathematically as unknown angles. So I'm going to use theta here. So we're going to say that in this case, for an acute angle, we're going to have this between 0 and 90 degrees. Good morning. Now, for a right angle, that theta is going to be equal to 90 degrees. So acute is between 0 and 90. Right is equal to 90. Obtuse angle, this is going to be where theta is larger than 90, but less than 180. And a straight angle, theta is equal to 180 degrees. Okay, let's take a look at some of these diagrams. These can be a little tricky. You notice these little arcs you see here. I mentioned those earlier. So anytime you see one arc, that means that these two angles are congruent to each other. Or you'll see two arcs. So look for another angle that has two arcs. Those are congruent to each other. Then you got three arcs. Same idea. Those will be congruent to each other. So it says angle CBJ. So let's find CBJ. B has got to be the vertex. It's in the middle. So here it is. CBJ. It's got the two arcs. Here's my two arcs right here. So we could call this, for instance, FHG. So those two angles are congruent. Okay, let's take a look now at the next one. FJH. So we'll start at F, move down to J, over to H. Notice that I have three arcs on the inside of that. So I'm going to look for another three arcs, and it's right across here. These are actually called vertical angles. We'll discuss that later. But we could call this AJB or BJA. I'm going to call it AJB. Okay, let's come down here. Says if the measure of angle EFD is 75, and that would be 75 degrees, of course, then the measure of JAB is equal to what? So EFD FD is up here in this corner. All right, so I'll go ahead and I'm going to write 75 up here. Notice it has one arc, so we find this one, and this is the JAB. That would also have to be 75 degrees. It says the measure, then erase those. If the measure of angle GHF is 130, okay, let's find that one. So GHF, so right here, and then write that 130. Then JBC, so let's see here. So JBC, it's going to put it with the two arcs. That's also going to be 130. Okay. Talk about angle bisector. Last section we talked about segments, and we talked about a segment bisector. Remember, that cuts a segment in half. So an angle bisector is a segment, ray, or line that divides an angle into two halves. So let's go ahead and take a look. We have KE, which is a ray. So ray KE is the angle bisector of angle K. All right, so let's go ahead and draw an angle K. Okay, so there's angle K. KE cuts it in half. So I'm going to go ahead and label that point. There's E, there's a ray. And then, like we did in the last section, we need to show that these are congruent. I'm going to put one arc there. I'm going to put another arc up here. Notice how they're a little offset. If I was to put them together, it'll look like one arc. So I want to kind of show those are two separate arcs. So that's going to then say that these two angles are congruent. Let's do a couple examples. What you might want to do at this point, if you'd like, is you could pause the video and try these on your own, or you can just keep going along. Either way, here we go. It says AT is the angle bisector of MAH. So we have a ray and an angle. So this is cutting this in half. So just temporarily, I'm going to put those as equal. So we've got some flexibility here. I'm going to make up this number. So it says, first of all, that TAH, that's this one down here, is 4x plus 20. Now, both of these angles look to be acute. The whole thing looks to be obtuse. Let's go ahead and make MAT equal to, let's say 50 degrees. Okay, so we'll put that right there. Okay, so now it says find x. So if this is equal to 50 degrees, let's go ahead then and set these equal to each other. So we'll say 50 is equal to 4x plus 20. So I'll go ahead and I'll subtract the 20, and I'll get 30 equals 4x. We'll divide both sides by 4 to isolate that x. So I'll get x equals 30 over 4. Now we can simplify that or turn that into a decimal. It's up to you. So I'm going to write it both ways. So I'm going to simplify this. So if we cut both of these numbers in half, we'll get 15 halves. That's a great way to write the answer. Or that's also equal to 7.5. So this problem, we had the flexibility to choose what we wanted. I chose 50. You could have chose something different. Notice we have the same idea over here. It doesn't say that we have an angle bisector, but it does say that LOV is congruent to VOE. So I'm going to go ahead and mark that like so. It says that LOV is equal to 7x minus 14. So let's go ahead and put that in. That's 7x minus 14. Now what I'm going to do is I'm just going to make up something for this other side. So we could do this, for instance, as an expression. So let's try an expression this time. Let's make this maybe 5x plus, let's say, maybe 10. How about that? Okay, so now let's go ahead. It says find x. So let's set these equal to each other. So 7x minus 14 equals 5x plus 10. So I'll go ahead and I'll subtract the 5x. I get 2x minus 14 equals 14, and I get 2x equals 24. That gives me an x equal to 12. Okay. So now, one thing I want you to be aware of is that many times in geometry when drawings are not drawn to scale. So if you look at this here, this angle looks to be acute. And we would all agree with that. That means if you cut it in half, certainly these would be acute. Based on the expression that I chose, we got an x equal to 12. And the next part is to find the measure of angle LOV. If I take that 12 and plug it in, so LOV was 7x minus 14, so I'll go 7 times 12 minus 14. 7 times 12, you can do that mentally, or you can use a calculator, that's fine. But we're going to end up getting 84 minus 14, which gives you 70 degrees. Now, 70 degrees is acute, but if you were to do 70 and 70, that's 140. Doesn't seem to be correct. But remember, not all drawings are drawn to scale. So I'm going to write this right over here. Not drawn to scale. That's something you're going to see quite a bit. All right, so you've learned some good stuff about angles. So you can come down here if you want to summarize your notes, you can. I wish you all the best. Take care.